Good morning, students. Welcome to our session. In previous video, I started lesson 4, metals and non-metals. In that lesson, suppose a material is given. How we will find out that material is a metal or non-metal? Then how we will find out that the given material is a metal or non-metal? For that, we have to study the physical and the chemical properties of metals. Once again, repeating, we have to find out the physical and the chemical properties of metal. Then we can find out the given material is a metal or non-metal. So previous video I explained about the physical properties. Once again I will revise that points, then I will continue and I will explain the chemical properties of metals. See here. What are the physical properties of metals? Metals have lustrous, sonorous, malleability and ductility and conducts heat and conducts electricity. So, if all metals, not if, all the metals conducts heat and conducts electricity and they have the properties of lustrous, sonorous, malleability and ductility. Once again, I will revise this. What is lustrous? Lustrous means metals have the bright surface and metals reflects the light. When light falls on the metals, these metals reflects the light. Such property we'll call it as lustrous. Mirror has lustrous property. It has a bright surface and it reflects the light, but it does not comes under a metal because it is that mirror should obey all remaining all the properties. Only the mirror follows only the lustrous property. Now coming to the sonorous. Sonorous means when you drop the metals, it produces a ringing sound. It produces a ringing sound. Most of the metals, they produce ringing sound. So they are sonorous. All the metals are sonorous. Suppose if you take the non-metals, carbon powder, like a coal, wood piece, you take and drop. You take one metal and drop, and wood piece or chalk piece, you take it and drop. And observe the difference between the sounds produced by these metals and non-metals. All the metals produces ringing sound. Next, malleability. What is meant by malleability? Malleability means by beating that metals, you can make into the sheets, thin sheets. Gold, silver, iron, all you can convert into sheets. So all the metals, they have the malleability. But non-metals, you can't make sheets. Carbon, like a coal, you take it and beat several times, you will get a powder. You can't make it into the sheet. Even the sulfur, all the metals, they are brittle. So, and you cannot convert into the sheets. Ductility. Ductility means metals, you can make it into, you can drawn or you can make it into the wires. You can make it iron wires, aluminum wires, copper wires. Means you convert into the wires. So that property we'll call it as ductility. But non-metals can't. Conducts heat. When you heat iron object, then the heat is uniformly distributed throughout the metal. Suppose if you take a vessel and you place it on the stove, then you heat it, you cannot touch the vessel at the upper part or the middle part or any part. When you touch it, you get hurt, your hand becomes burn, because whatever the heat is absorbed by the metal, it uniformly spreads. So from this you can say that it conducts, all the metals conducts heat. Next, conducts electricity. For this also, for the wiring purpose, we are using the copper wires. All the metals, not only the copper, instead of the metal, you cannot use wooden wires or the plastic wires. Only you can use as a metal wires. Means all the metals, means they are allowing to pass the current through them. So that we'll call it as conducts electricity. So these are the physical properties. By only the physical properties, you cannot decide the given material is a metal or non-metal. We have to discuss about the chemical properties. So now, what are the chemical properties? Yeah, the chemical properties. When the metals react with oxygen, when metals react with oxygen, and metals rusting of metals, and the reaction with water, and the reaction with acids, these are the chemical properties. By this physical and the chemical properties, you can find out, or we can find out, the given material is a metal or non-metal. Now each one I will explain. First one is the reaction with the oxygen. See, this reaction with oxygen, we have the lab activity. Each lesson we have one lab activity. So this is lesson 4 and we have 4th lab activity. So what is that lab activity? What is the aim of this? Here we have the lab activity for the reaction with oxygen. When metals and the non-metals, how they react with the oxygen. Here you see, what is the aim? To know the reaction of oxygen with metals and non-metals. How these metals and non-metals react with the oxygen. What are the products we will get? What are the end products we will get? Next, for to do this activity, lab activity, what are the materials required? Here we have to we are discussing about the metals and non-metals. So you have to take the samples of one metal and one non-metal. So metal for magnesium, non-metal for sulfur. So here I wrote like symbols only. Magnesium we can represent with Mg, sulfur we can represent symbolically S. So you take one metal and one non-metal spirit lamp, because we have to heat it. So for that either you take spirit lamp or Bunsen burner. See, Bunsen burner means by using the gas we can burn it. Here spirit lamp means you can take the liquid, either kerosene, by using that you can use. Next, litmus papers. These are the materials required for this activity. Now, here I will rub it and I will explain. Now, what is the procedure? First, you take the metal. Here for the metal, what we took? Magnesium. Here we took as magnesium. See, this is a metal and non-metal is sulfur. So first we'll take the magnesium metal, and you take this, we'll get as a ribbon, long like a ribbon will get, and you take a small piece of this magnesium metal, and by using the tongs you heat it, this magnesium. Actually that magnesium is having a bright surface because it is a metal, so it has a bright surface, and when you burn it, magnesium, by using either spirit lamp or the Bunsen burner, it burns brightly, dazzlingly, means it gives more light. Okay, after burning we'll get ash, so you take the magnesium and you heat it. When you heat it, you are getting ash. So collect this ash. We'll discuss about this non-metal later. So when you heat this magnesium by using this, and you will get finally ash. Ash means, you know, it is in which color? White color or gray color. So collect this ash in your tissue. Collect this ash, that powder, in your tissue, and add distilled water. You add distilled water, shake it, closing the tissue and shake it. You will get a solution. You will get the ash water otherwise. Then in that water you take litmus papers. We have blue litmus and red litmus papers. So take the 2 litmus papers and dip in the solution. Blue litmus and red litmus. These 2 litmus papers you dip into the solution and you observe which litmus paper turns or the changes the color. You can find out there is no change in the blue litmus paper, but there is a change in the red litmus paper. So this red litmus paper, it turns into blue. It turns into blue. So here when the red litmus turns into blue, then whatever the solution we have, that it has a basic nature. It has basic nature. Once again I am explaining the same this property, where take magnesium and heat it, you will get ash. That ash you collect in the test tube and add some distilled water, shake it. In that solution or in that ash water, you take the 2 litmus papers, you dip in that and find out which litmus changes the colors. So here there is no change in the blue litmus, there is a change in the red litmus. So the red litmus changes into blue color, means when red changes into blue, then it has a basic nature. From this, when metals react with the here what we are discussing, oxygen. So when metals react with oxygen, they are giving, means they are producing some oxides. They are producing some oxides. So whatever the ash is there now, and that it is a oxide. So that oxides, they are producing the metal oxides, and these metal oxides are having the basic nature. Very, very important. Even the same lab activity you have in the 10th class also. So when metals react with oxygen, they produce metal oxide, and these metal oxides are in basic nature. Understand? Now we will discuss about the non-metals. Now take the non-metal. So here we took non-metal as sulfur. So take sulfur. This we can get in the powdered form, and the sulfur is in yellow color. The sulfur is in yellow color. Actually the sulfur is used in the ointments and in the fireworks also they are using this non-metal. Now sulfur powder you take, and you have to take in a deflagrating spoon. Means what? Generally we are using the spoons. So here that spoons are like this. Spoons are like this. But here the deflagrating spoon means it is having like this. Straight. So this is known as deflagrating spoon. So take this spoon and take some sulfur powder in that deflagrating spoon, and you start heat it or burn it. When you burn by using this spirit lamp or the Bunsen burner, when it catches, when it starts burning, as soon as the sulfur starts burning, it gives fumes. Some gases are releasing. So means fumes comes out. At this condition, this deflagrating spoon, you must keep into a closed jar. You must close it into a closed jar which is having the lid. Once again, you take the deflagrating spoon and you take the sulfur powder and start heating. When you heat or when it is burning, when sulfur powder is burning, it from that some fumes comes out. At this conditions, immediately the deflagrating spoon, just you must enter into a closed jar. Closed jar means it has that lid, upper part, it is having some hole to keep this deflagrating spoon along with the lid. So you must close it. So whatever the fumes are coming out, that you can collect in this jar only. So these fumes cannot escape from the jar. Okay, so close with the lid properly, and after completing this burning, then take out this deflagrating spoon and add water, then immediately replace that lid. Then immediately replace the lid, because your gas, you collected the gas, it should not escape from the jar. So after removing this spoon, deflagrating spoon, immediately you must add some distilled water in that. Replace this lid. Then shake this lid. Then you will get a solution. You will get some liquid, because whatever the gas and that water both are mixing, will get some water. In that, again you take the 2 litmus papers, blue and red, and you dip in that water and you find out which litmus paper changes or turn into color. Here, when you place red and blue, there is no change in the blue litmus paper. There is a change in the red litmus paper. Here in this non-metals, red litmus paper changes or turns into blue color. So when red litmus turns into blue, it indicates it is an acid. It is an acid. So here this oxide or this solution is having the acidic nature. That water, it contains acidic nature. How does we get like this one? Here, when non-metals react with oxygen, they too produce oxides. When metals react with oxygen, they produce metal oxide. When non-metals react with oxygen, they too produce non-metal oxides. Both they produce the oxides. So here they produce non-metal oxide, and this non-metal oxide is nothing but the water. So that water, when you test it, it changes the red litmus into blue color. So means that non-metallic oxides are having acidic in nature. So this is about the lab activity. What is the observation? And here, after while you are doing this procedure, here we have one table. What is that table? Sample, appearance before reaction, appearance after reaction, effect of litmus paper. So here you take metal, magnesium, non-metal is sulfur. Here before the reaction, magnesium is having the silver white color, and sulfur is in yellow color. That powder is in yellow color. Appearance after the reaction. So we will get magnesium when you react with oxygen, we will get ash. Ash is in either grey or white in color. Next, it produces fumes, gases. That gases are colorless. You cannot find it. Colorless gas. So colorless. So for the magnesium, that litmus paper red turns into blue, and for the sulfur, blue turns into red. When red turns into blue, it has basic nature, and the blue litmus turns into red, it has an acidic nature. This is very, very important. Even you have this lab activity in 10th class also. Understand, children? Now, last one more step. When metals react with oxygen, and finally in observation, what observation you can find out through this lab activity. When metals react with oxygen, they produce metal oxides, and they are having the basic in nature. Now next, non-metals react with oxygen, they too produce non-metal oxides, and they have an acidic nature. They have acidic nature. So this is about the reaction of metals and non-metals with oxygen. So we have 4 chemical properties. Just now I explained only one property. Next, I'll continue the remaining. Next one is Rusting of metals. Generally, when you leave the iron things, when the iron objects are exposed to air, what is air? Air means it contains different gases and moisture. In the gases, we have carbon dioxide gas, sulfur gas, oxygen gas, nitrogen gas, different gases along with water particles also there in the air. So, if you take the iron objects, these iron objects react with air, and in the air also they are not reacting with the air means it contains some components. Components means different types of gases and water particles. So the iron objects react with only with the oxygen and the water particles or the moisture, then it forms oxides. Iron when react with oxygen and moisture, it forms iron oxide. That simply we'll call it as rust. We'll call it as rust. So these iron objects within a short time they convert into the oxide. But if you take the gold, when you're exposed to air, they do not react with the air or the components of air, like platinum also. But when you take other what are that, copper vessels, and one more is silver articles we have now. So silver and the copper, these articles, when you buy, they are very shiny surface, like smooth and shiny surface. But when they are exposed to the air, air means different components at the different ratios, at different conditions, these metals are reacting. So when they react with the components of air, then they become dull. So if you find new silver articles are very shiny, but after usage you can see the duller, that surface is dull. Even the copper vessels also same like that only. It becomes like, it turns into the greenish color, like blackish color, like that. Even magnesium also, it has a shiny surface, but when it is exposed to air, even the magnesium also, it becomes dull. So here all the metals, they are reacting with the air, and in this reactions, some metals immediately they are reacting with the air, and some it takes slow, and some they do not react with the air. Components of air at different conditions and at different proportions. Now, how to avoid this rusting? Generally we'll use painting. Why do we prefer painting for the windows? And the windows means they're having the iron rods. So why do we prefer? Because to avoid the rusting. So when there is a layer of painting of that iron object, they will not react directly with the components of air. So like that you can avoid the rusting. Next, third property. Reaction with water. Reaction with water, we have different metals: sodium, magnesium, iron, copper, gold. We have the different types of materials. In all these materials, the metals react with water. Where here, if you take the sodium is very reactive with the water than compared to the other metals. So that's why this is sodium, and one more is phosphorus. Phosphorus is completely different. It is a non-metal. We'll discuss about the metal. So this is sodium. Always they are stored in a kerosene, in a liquid of kerosene. once again, take sodium metal, and this sodium metal at the room temperature, it catches fire. It is highly reactive. It is highly reactive. So that's why always they're storing in the kerosene. They preserved in the kerosene. So from this kerosene, you take from this sodium metal a small piece, you take it, and you take one trough which and you fill with water, and in this trough you fill with water. Okay, here we are discussing about the reaction with water. How does the metals react with water? For that, first we are taking about the sodium metal. So this sodium metal is preserved in kerosene. Why? Because it is very reactive, and it is extremely very reactive, and at the same time dangerous. It catches fire easily at the ordinary temperature. So from this kerosene, you take a small piece. You should not use your free hands. By using the forceps, you cut a small piece of sodium, and you have the blotting papers like filter papers we have. So take that paper and you place it that small piece of sodium and leave it, because this sodium is preserved in the kerosene, so it contains some quantity of kerosene. Let them absorb by that paper. Then after that, this metal, sodium metal, just you drop with the tongs. You should not use with your free hands. So just drop into the water, that sodium metal. When you drop this sodium metal, immediately it produces hissing sound. When you open the soda bottle, you will get, when gases comes out, it produces a sound. So like that you will get when the sodium metal is put in water, it produces, the sodium metal produces hissing sound. Means the metal is dissolving in the water. While it is dissolving, it produces an hissing sound. Means this sodium is very reactive with water. It is very reactive with water. Now you take the gold piece, small piece, and iron or copper, these metals, and you drop in the water. Will you get such sounds? Will they react with water directly? Even this gold, if you leave 1 year, there is no change. But iron, it becomes rust. Iron also we don't know, but it takes time. So like this, we can't get that reaction. So the sodium immediately react with the water, but other metals, it react with the water, but extremely very slow. It takes time. Means they do not react with water. So even the non-metal also, they do not with the water. You take coal powder and dissolve in the water. Is there any reaction? No. Like that. Next, the last property is reaction with acids. How does these metals and the non-metals react with acids? The same property you have in the 10th class, and you have in the form of lab activity, and it is the 4 marks question in 10th class. So this property also important. Here is reaction with the fourth property is reaction with acids. Here, what is the reaction with acids? When the metals react with acids, what we will get? Same, non-metals, when they react with acids, what we will get? That we have to discuss in that. For this, you take one test tube. In that, you take a metal piece. Here you collect metals and non-metals: iron, zinc, copper, sulfur, aluminum, carbon, magnesium, iodine. So in all these samples, some are metals and some are non-metals. Iron is a metal, zinc is a metal, copper is a metal, sulfur is a non-metal, aluminum is a metal, carbon is a non-metal, magnesium is a metal, iodine is a non-metal. So you collect it. And for example, here I am taking the zinc metal. You can take any metal. So here I am taking zinc metal. So you take one test tube and take the zinc power granules will get. Okay, so that granules you take 2 or 3 in that test tube and take. For this you must add 5 ml of dilute hydrochloric acid. It is named hydrochloric acid. Shortcut I wrote it as HCl. Here these acids we have two types, dilute and concentrated. Dilute means that solution contains more quantity of water. Concentration means the water quantity is less. Suppose if you take 1 cup of milk, if you not milk, okay, suppose if you take 1 cup of milk, if you add 1 spoon of sugar, it is diluted. If you take 10 spoons of sugar in that cup of milk, then it is concentrated. So we have the two types of solution. So you take the dilute hydrochloric acid and add to this zinc metal, and after that you will get from the test tube, while you are adding this dilute hydrochloric acid, you will get some fumes are coming out. Means some gases are releasing. When the gases are releasing, immediately you bring one burning matchstick, and you just place it near the neck of the test tube. Don't put inside. Just you bring near the neck of the test tube where the fumes are escaping. Then these fumes, they are making this burning matchstick, making the sound pop and put off the flame. Means when metals react with, here hydrochloric is an acid, it is a powerful strong acid. When they react with acids, they liberate some gas. So the gases, they are escaping through fumes. Okay, so this here oxygen is helping for the burning of any object. Hydrogen gas means it put off the flame. So here when you bring the burning matchstick, it put off the flame and it is making the sound pop. So that gas indicates hydrogen. Means when metals react with acids, they liberate hydrogen gas. This is very important bit. When metals react with acids, they liberate hydrogen gas. So instead of this zinc, you take different metals and do the same. Suppose if you are not getting fumes, you heat this test tube. Even though if you will not get fumes, then instead of this dilute acid, you use the concentrated acid. Then definitely you will get fumes, means it liberates gas, and that is the hydrogen gas. Hydrogen gas is always put off the flames by making the sound pop. Now we'll discuss about the non-metals. So here instead of this zinc, then you take a non-metal and do the same. Here non-metal means you take sulfur powder or coal powder. Any you take sulfur powder or any one you take it and add water, dilute hydrochloric acid, and you find out if you are getting any fumes or not. You will not get any fumes. Like metals, you will not find any type of reactions. Means these non-metal oxides, they do not react with the metals. Only the metals, they react with acids and they produce hydrogen gas. So these are the about the chemical properties of metals. I'll discuss about uses of metals and non-metals in another video.